Hello, in this video I'm going to cover how to use Docker and the CLI to do something useful in a container related to programming. So at this point you should be familiar with basic interaction with Docker over the command line interface, the CLI, and running containers like a basic web server, Nginx. However, you may want to not simply run a program, but you may want to develop code inside of a Docker container, or you may want to use a certain development toolchain that is available inside of a container. So let's take the example of Python, a very popular programming language that requires you to install a Python interpreter on your computer. So let's say you don't have a Python interpreter, and if you were to type just Python into your shell, you wouldn't get anything. I do because I have some Python installed here, but you might not. So how could you run that inside of Docker? Well, you could go to Docker Hub and look for Python, and then you could pick a tag of Python that you like. I'm going to look for maybe an Alpine version of Python, and there's an Alpine 321 version, so I'll take that. And I can Docker pull that, or I can simply Docker run, and it will pull for me. So let's Docker run Python, and let's see what happens by default. Nothing. So it just exited, and I have some other containers hanging around here, so I'll just quickly delete those, which will stop and delete them. And nothing is happening here with Python. So that's because the default command for Python, which we can find with docker inspect, it's a bit hard to see what's going on here. There's a lot of confusing things in here, but the command that this runs, there's no entry point, and there's a command called Python 3 that it runs. So when you run Python, like I just did in my native terminal, you see it's an interactive terminal. So you should know at this point that when you want to run an interactive terminal in Docker, you're actually going to need to specify that you want to keep standard input open and that you want to have a terminal interface inside of there. And so when we do this instead, we're going to automatically attach, because we have not used the -d flag. So we're going to automatically attach to that, and we'll see a Python prompt. We can do like 8 times 8 times 8 and get the result, because this is Python. So we could do for I in range 18 print I plus 1. And we get the numbers from 1 to 18 printed out. I'll hit Control D, which will exit the Python shell, and it'll also in turn exit the container. And you can see that Docker PS, nothing running, but Docker PSA, there will be those exited containers because we did not set them to remove on exit. So we'll have to Docker container prune -f to get rid of those. So let's run this and have it --rm on exit, and let's have it --name be pyc for container. And so I'll go ahead and run that again, except this time let's see if there's a bash shell installed. No bash shell. Let's see if there's an sh shell. There is an sh shell. So I'll say, who am I? Is there who am I? Yeah, I'm root. So let's see, ls, the base file system, has the standard files you would expect. Let's see, ls home. Is there anything at home? No, so there's probably no other users except for root. So let's see the root folder, which is the home folder for root. cd root ls. Nothing in root. Okay, so I'm going to exit there. I have some visibility. I know that the user I'm expected to use in here is root, and I know that they have an empty home folder at /root. So if I want to write some Python files in here, I'm probably going to have to access the file system of the container so that Python can access that. And I might want to write that code and edit it on my host system, but then go and run it inside of the container. So how could I do that? Well, first let's see about mapping a working directory so that we can share our code between these two. I'm going to open the File Explorer and go to Home. Now, Home in this way is a little confusing in Windows. Your home is really at this PC your C drive or wherever your OS is installed, and then users, your username, and this is really your home folder. So I'm gonna go in here, and you should create a code folder either in your documents or somewhere you'll find it, or in this home directory. And so I'm just going to pin this code directory using right click, context menu, and then pin to quick access, and I already have it in quick access. So I'll create a folder here, new folder, and I'll call it Docker Playground. And then I can open that in multiple ways, one of which is create a new VS Code window, and then File, Open Folder, and open from the sidebar Code, and then pick the folder I just created and select Folder. So now I'm in here and I create files like program.py. Now I can put Python in this. And I like this, except I'll do +1. So how can I run this in Docker? Well, I'll create a terminal with Control-Shift tick mark, which is above the left tab key, Control-Shift tick mark. And now I will make this full screen, make it bigger, and Docker PS, where were we? And I will take my command from over here. So I have this file on my host system, and it's in this path, but this is on my host system, and my if I do this and pwd, I'm in a completely different place. I'm in the root file system. So let's say I want to use the home directory of the root user, which would be a reasonable place to put some code. So I will say --workdir, and I will pass that to /root, which is the root's home folder. And I'm going to get an error because Git Bash is trying to be smart with this path and translate it into a Windows path, but that's not really the behavior I want. So because I'm in Git Bash, I have to add this annoying thing. I'll hit Control A to go to the beginning of the command, and then do msys _no _path conv for path convert equals 1. And that just says set this variable only for the running of this Docker command right here. And so when I hit enter now, this should work fine. And I'll say pwd. Now my working directory is /root, that empty folder. ls, it's empty. Control D to exit. And since we have RM, this is cleaning up after itself when we're exiting out of that, and it's not running anymore. So what I'm going to do is try to get this into here. So one way would be to start the container, not with RM, and then to copy this file using docker cp program.py, and then I could copy it to the container, say pyc :/root. I could do this. But what I want to do is actually create a volume between my host system and the container. So let's try the first method first and see what the advantage is there. So we'll add to the IT flags, we'll add D as well. It'll go detached and it'll keep running. So we can then docker cp program.py to pyc :/root /program.py. And we'll probably need that msys path, no path conv, because we're mapping some paths here. And it's successfully copied. So if I do a docker exec of pyc sh, run the exec in the pyc container, the sh program interactively with IT, and I do ls, we should see program.py. So now we can do python program.py, and it'll run. Now the problem is if I edit this file, like let's say I do echo \n for new line and say print hello \new line, and I echo that and append it to program.py. If I do cat to print out the contents of program.py, I'll see that maybe these were supposed to be /, I don't know, but it didn't really change anything on the host system. So let's see if I can even run that. If it's, yeah, it's probably messed up. But anyway, you see that it didn't change on the host system. So I'll hit Control D, and you'll see now also what happened is the container's still running because I have an interactive terminal set up to stay open, a separate one from the one we just exec'd. But if I docker stop pyc, it will remove itself because that's how it was configured. And so now that program that we copied into there, that in turn is also going to be gone. We can't get it back now because we manually copied it into that running container. And you can only do that Docker CP into a container that's still around. So how do we get around this? Well, we can do a volume approach instead. So what this is going to do is map program.py to program.py inside the container. And we'll do that with -v. Now, it's very important that we have this msys no path con for git bash whenever we're dealing with paths, and volumes deal with paths. So volume is going to say pick a place on our host directory. So we would normally do // like program.py, but this command actually doesn't work with //. So we're going to have to use the output of print working directory, pwd, and then that will essentially give us the same thing as // and we can map that to say prog.py in the container, except we want it to be at /root /prog.py. And we've accidentally split up our workdir, so we need to put the workdir /root back here. And then let's see. Oh, I should have run this in the foreground instead of the background, like this, but now the name is going to conflict. Let's just run a second one called pyc2, and we see prog.py. And so now we can run /prog.py, and let's create a new line here. And run it. Oh yeah, it's not. So we can't run // because it's a Python file. So Python prog.py, and it's going to run through. So now if we were to make an edit either from here or from here, it's going to reflect in both places. So if I said print done, and I run this from here, it's going to have print done. Or if I said make a new line so we can easily echo, we're going to say echo print hi. We may need single quotes here, not sure. And we'll echo that to the appending to the end of prog.py. We'll see we get that reflected in the host system. And the nice thing about that is now not only does it work from both sides, now when we Control D and exit this container, this was pyc2, remember, not pyc1, so we can docker stop pyc1 as well. You'll see that our file is still here just as it was before. So this is a great way we can just map a program right into a container, and then we can save the output once we're done, even though the container is now deleted and gone. So to move on and do one more thing, I will show you how, what if we have a file that outputs. It's a common thing to run code and output a file from code. So let's say we want to output hi mom from to a file called hi.txt. So that's pretty good Python code. We're using write mode to write to that file, and we can run the container and just go ahead and directly run python program.py, except it's called prog.py inside of there, and it'll run and it'll create that file. But where is the file? Well, our container has been deleted because we did rm, so we can't get that file. So we actually need to map that file. Now we don't have to map every individual file. Instead, we could just map a folder instead. So we'll create a folder called src, for example, and we'll put our program in there. And then rather than mapping the program file directly, we'll just map src, and we'll map that to the /root folder. Now when we run prog.py, it's called program.py because now it's using the original name. We'll see that hi.txt is put into that folder because this folder is shared both with the container and with the host system. So now, even though docker ps-a is going to show that container is exited, we got to keep our output from that. So you can see how volumes give you a much easier way to keep things around on your host system, even after containers have not only exited, but they have been completely deleted, and those files are now gone otherwise. So that should conclude it for this video. Thank you for watching.